Hello everybody. Today we will prove Archimedes Principle. Right? What is the Archimedes Principle? Archimedes Principle states that the upward buoyant force that is exerted on a body immersed in a fluid, whether fully or partially, is equal to the weight of the fluid that the body displaces. This is the principle of Archimedes. We will prove this in this experiment. Again we are repeating, Archimedes principle states that the upward buoyant force that is exerted on a body immersed in a fluid, whether fully or partially, is equal to the weight of the fluid that the body displaces. Right? This is the Archimedes principle. Now we prove this experiment. Prove this Archimedes principle in experiment. For that, what we take? We have taken a glass of water and put it on this vessel, on this. After that, we have taken this water, right, and we give water full on this glass, right. If I put something on this water, the water spills out and falls in this vessel, right? Now what we need? We need a spring balance. Here you see, we have a spring balance. Here you see, we have a spring balance. This is our spring balance, and we are trying to read the list count. Here you see the list count. List count is the smallest division in scale. Here you see, in 1 Newton there are 5 divisions, 1, 2, 3, 4 and 5. In 1 Newton there are 5 divisions, that means 1 Newton equal to 0.2 Newton, right? First of all, we measure weight of an object in air. We have taken an object here, this is our object. Let us measure this object in air. Here we are taking the weight of this object in air. Let us see what is the measurement of this object. Here you see, we have taken the weight of this object, and the weight of the object here you see is 1 Newton. Here you see, this is exactly 1 Newton. Therefore, the weight of this object in air is 1 Newton. Here you see, the weight of this object in air is 1 Newton, right? Now, I will measure this beaker, empty beaker. This is empty beaker. Let us measure this object. What is the measurement of this empty beaker? Let us measure this empty beaker. Let us measure the weight of this empty beaker. Here we are measuring the weight of this beaker. Here you see, we are measuring the weight of this beaker, and the weight of this beaker is nearly 0.2 Newton. One division, that means 0.2 Newton, right? That means weight of this beaker is 0.2 Newton. Only this beaker, okay? Right? The weight of this beaker is 0.2 Newton. Here you see, the weight of this beaker is 0.2 Newton, right? Now, we will find the weight of this object in water, right? Here you see, this is our water. Now, if I put this object in water, we will find what is the weight of this object in water. Here you see, we are putting this object in water, and let's see what is the reading of this object in water. Let us find. We are putting this object in water, fully immersed. Some water is displacing, right? Some water the water is equal to the volume of the object. Now we see what is the reading of this in this condition. Here you see the reading of the object is 0.8 Newton. Here you see. Let us see. Here you see, there are 4 divisions, means 0.8 Newton. That is, weight of the object in water is 0.8 Newton, right? That means there is an apparent loss of weight, that is 0.2 Newton, right? 0.2 Newton. Now, I am taking this out, and we have got the water which is displaced by that object in this container, right? Now we will take this water in this beaker and measure the weight of this displaced water, right? Let us measure the weight of this displaced water, right? Now we are measuring this weight of the water with beaker, right? What is the weight of the water with beaker? Let us measure the weight. Let us measure the weight of the beaker with water. Here you see, we are taking the weight of the beaker with water. What is the Let us measure the weight of the beaker and let us measure the weight of the beaker with water. Let us measure. As here you see, we are taking the measurement of water with the beaker. Here you see, the weight of this beaker with water is 2 divisions. Here you see 2 division in 0.4 Newton. 0.4, you see 0.4 Newton. And the weight of the beaker is 0.2 Newton. Therefore, the weight of the displaced water is 0.2 Newton, right? That is, we are getting the weight of the displaced water as 0.2 Newton, right? That means this weight of this water, displaced water, is 0.2 Newton, and we got the apparent weight. Loss in apparent weight is 0.2 Newton, that is same. And that is the Archimedes principle, right? Again, we are getting this water, this body, this object displaces this much of water when dipped in water, and the weight of this water is 0.2 Newton. And when you take the weight of this object in here, we get 1 Newton, and when you put in this water, the weight of the object is 0.8 Newton. That means apparent loss in weight is 0.1 Newton. And we see that 0.1 Newton is same with the displaced liquid. And this is the Archimedes principle. Right? Again, we are repeating that what is Archimedes principle? Archimedes principle is states that the upward buoyant force that is exerted on a body immersed in a fluid, whether fully or partially, is equal to the weight of the fluid that the body displaces. And also we are finding that there is an upward thrust. You can prove this also here, that if you put an object in water, it gives an upward thrust. Let us give it by an example, right? Here, if you see, if I put the pencil in this water, right, it gives an upward thrust. And you see, it is giving upward thrust and it rises up. You see here, this is the upward thrust, right? And this upward thrust is equal to the weight of the liquid displaced by this object. This is the principle of Archimedes. Again, we are explaining that Archimedes principle states that the upward buoyant force that is exerted on a body immersed in a fluid that is fully or partially is equal to the weight of the fluid that the body displaces. That means the buoyant force is equal to the weight of the fluid or liquid displaced by the object. And here we got the buoyant force as 0.2 Newton because the weight of the object in here is 1 Newton. Weight of the object in water is 0.8 Newton. Therefore, the buoyant force is 1 minus 0.8, that is 0.2 Newton. And the weight of the liquid displaced by this object, we also got 0.2 Newton. Both are same. Therefore, we can say that Archimedes principle states that the upward buoyant force that is exerted on a body measured in a fluid, whether fully or partially, is equal to the weight of the fluid that the body displaces. This is the Archimedes principle. We have proved this experiment of Archimedes principle. Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.